Good afternoon, everybody, and welcome to this Smart Metering Hub session in the European Utility Week in Vienna. I'm very happy that you all are here because we have a very, very good group of speakers this afternoon. This session will last for 3.5 hours. There's a coffee break in the middle, but we are starting at 2 o'clock and it's finalizing at 5:30. And we'll have seven interesting presentations from utilities in the electric sector and the gas sector that have developed large rollouts of smart metering. And also we have presentations from services provider on security, assets management related to smart metering, and other very interesting topics. So I think this is a complete session of information, and please feel free also to ask us questions after the presentations. We are going to give 1 or 2 opportunities for a question to each speaker after their presentation. And then we'll have at the end also a panel session where you could ask speakers about other questions that were not arise during these first speeches. Without more delay, I will start with a brief comments on the situation in Europe of the rollout of smart metering. As you can see, we are approximately 500 million Europeans, and we have approximately 300 million of metering points for electricity. We have a mandate to have approximately 200 million meters by 2020, but this will delay probably to 2023. And by the end of this year in Europe, we will have approximately 120 million of smart meters, most of them in a smart meter infrastructure, so connected to a base, to a system where the information can be collected and managed. These rollouts in Europe means an overall investment of approximately 45 American billions, so 45,000 million euros. And we are talking here mainly about electricity smart meters, but also a percentage of gas meters. Okay. In fact, in this session, we'll have a very interesting presentation from Gaz de France, which is doing a rollout of 11 million in the coming years. I coordinated a project called EU Smart Consumer, where we prepared a landscape report, a very interesting report on the situation of all European countries related to smart meter infrastructure. And this report is free. It's available in the website of the project, eusmartconsumer.com. And in this report, you will see a map of the situation. I will put a bigger map now of the situation of the countries, the regulation in all countries, and the market implementation in the 28 countries plus Norway, European countries plus Norway. The European legal framework, so mainly the directives that are linked to smart metering, but also the services for consumers. We are not talking only about a machine, a smart meter. We are talking about what to do with the machine to benefit the customers, the consumers. This is something new for you. It's totally new for today. Is the situation of the European countries in smart metering. We have in this axis here. So in this axis here, you have the market implementation of smart metering, and here you have the regulation implementation. So if there is a regulation in the countries. This map, we have doing this map, we have been doing it for the last 5 years. So we have the maps for 2013, 14, and so on. And we have seen the movements. These are these arrows from the different countries. Some countries are going to the front runners, so countries with large rollouts, and also clear regulation in the countries. Finland, Spain, so Nordic countries, Italy, Spain, and all the large rollouts. But also there are many countries which are reaching these front runners, which are dynamic, very dynamic in these last years, like France, the Netherlands, Austria, UK. They are really catching up in these last years. We have some other countries in the central which are still thinking about how to do the full rollout, like Germany, for example, that you know that they are not doing the full rollout until 2021 for small consumers, less than 10,000 kilowatt-hour consumption. So homes mainly are not still having a smart meter. Here there is a different color spot, which is the U average 60-60. This means more or less we are in 60% of progress in legal and regulation and 60% in market. That doesn't mean we have 60% of smart meters in Europe, which means that we have a strong movement, but we are considering here not only the smart meter, but also the infrastructure to provide to the consumer some information. Okay, so we have appliances, we have displays, or we have internet-based systems that you provide hourly data, or you provide benchmarking of consumption, or you provide some information to the consumers. Okay, so we are talking about meter and infrastructure for the consumer. Yeah, the main regulation at the level of Europe is the European Energy Directive, which should be an efficiency directive, which should be updated this year. And mainly what this directive says is that all countries should provide to the consumers, to the customers of electricity, natural gas, district heating, district cooling, and hot water, some individual information. That's what it says. Always that there is a cost benefit, and the cost benefit is not negative for the country. Okay, that's the reason, for example, that Germany is delaying it, because the cost benefit for a smaller consumer is not so good in this country. And when we talk about this information for consumers, we are talking about this. We are talking about some information in the website, for example, the hourly consumption for the customer, or the benchmark with other customers with similar homes, for example. We are talking about displays at home, also providing information on the weather, for example, so you know if your consumption in the boiler is related to the weather or not. Or we are talking also about real-time information on the consumption, and maybe not only kilowatt hours, but also euros. People know a lot about euros, and sometimes kilowatt hour is something more not so fancy. Okay, this is a little introduction from me, from the chairman of this session. And now I would like to welcome the presentation on Prime 1.4, changing the rules of the game. We have speakers. We have two speakers. We have Ali Mufla, right? Mula, sorry, and Mohamed Abel Mouniem. Please, the floor is yours.
This moves it that way, yes, and then the pointer. The pointer is. Oh, okay. No, it's okay. Hello, everyone. We're honored actually to be presenting today the first deployment of Prime 1.4 in, I think, worldwide in Egypt, and we're going to share with you guys some of the vision of the holding company in Egypt, as well as some of the results, the interesting results that we achieved in the field. So to start off, I just want to introduce the Swedi Electrometer very quickly. The company is based in Egypt, but it's a global company, so it has facilities worldwide in India, Ethiopia, Ghana, Zambia, in Mexico. So the Czech Republic, of course, we have our company, ZPA Smart Energy, and the thing is that we've experienced so many different scenarios, so many different situations in the field, and it all culminated in this project in Egypt. This is some of the projects that we've been working, some of the smart metering projects that we worked on in Egypt, in the Czech, of course. There's a pilot in Ghana, of course. There's a rollout of 200,000 meters smart using GPRS communication technology. The unique thing about the Egypt project is that it's primarily using PLC communication. And I'll explain why that's so unique. In Lebanon, of course, we have a project for 470,000 meters. This project was more of a collaborative effort between members of the Prime Alliance, and we were very proud of this ecosystem that we managed to create. So the meters were actually provided by ourselves, but we also were supported heavily by Microchip and their communication technology. Abdelmenem, would you like to elaborate a bit?
Actually, the owner of Microchip is giving to us. Actually, Microchip is just joining.
Yeah, there he is. I wanted to see if he's going to actually show up. Yeah. Alfredo, please, the floor is yours.
Hi. As my colleagues was commented, Microchip is one of the main provider of PLC technology. We are from the early stage in the definition of Prime technology. Microchip is one of the bigger silicon provider company with more than 80,000 employees in all the world. The headquarters for the design of PLCs is in Spain. It's my group, and we work on this technology for the early days. We had more than 10 million of chip on PLC and more of 4 million of chip on Prime. And we are also leadership the definition of Prime 1.4 from the early data also. Then we are prone to collaborate with Elsewedy in the project of AGIT that then they will comment now.
Thank you. Speaking very quickly about the project in Egypt, the vision of the holding company in Egypt is to try and have some sort of hybrid communication solution where you're not dependent solely on one specific type of communication. But they wanted to try and benefit from the fact that PLC communication is the most reliable, it's the most secure, it's the most robust, and at the same time, they'll benefit from the fact that the infrastructure is already there. And this is something that we couldn't have done had it not been, for example, for the new technology that we're seeing today in PLC, like such as Prime 1.4, and the variety and the robustness that we see there. The holding company in Egypt is trying to implement this project in phases. So the first phase is approximately 250,000 meters in 6 distribution companies, 6 different varied distribution companies in very different environments. Some of them urban, some of them suburban, some of them rural. And this is why the beauty of modularity comes in. All of these different metering solutions will actually be integrated together in one MDM system that will be based in the holding company. On the part of Elsewedy Electrometer, we were allocated 63,000 meters out of the 250. We were allocated 3 different deployment areas. One of them was in Cairo. Another one was in Minya. Minya is one of the most rigid and one of the noisiest environments in probably all of Africa. So the fact that we implemented Prime PLC in that sort of environment and the results that we're going to show to you guys were very promising. It signifies the fact that Prime PLC can be depended on in much better environments, and this is something that we hope will be very, very powerful. As I said, the choice of the communication technology to choose varies on different factors. For example, how many meter readings you want per day, the security issues, what sort of density you're dealing with, what sort of environment you're dealing with, different choices, different options. And the project in Egypt allowed us to actually have a mixture, a combination, a perfect storm, if you will, of all of that. It was an urban, suburban, rural project, overhead cabling, underground cabling, lots of noise. And this is the beauty of that project. The project, it was not deployed in one area. It tested deployment in 3 different areas with unique environments, as we said. Okay, so as we know, and I'm not going to delve too much into this, but any smart metering solution depends on 4 main pillars. The 4 main pillars are, of course, the metering part, the communication devices, which communication type do you want to use, the head-end system that will, at the end of the day, integrate all of these meters together, and finally the IT infrastructure, which has to be scalable and it has to be rolled out with the meters, because it has to actually scale up and expand with the expansion and the rollout of the number of meters that you're going to be installing in the field. If you think about such a project, some of the time these projects fail because there's no system integrator. At the end of the day, you bring all of these hybrid solutions, you bring in different software, you bring in different communication devices, but if you don't have a strong ecosystem, if you don't have a system integrator to oversee this ecosystem, the project is likely to fail. And this is why we at the Prime Alliance, for example, believe in our ecosystem. We believe that the collaborative effort, the spirit of having Microchip supporting Elsewedy, companies like from the communication devices like Telecom, for example, going into the field with us and supporting us in the field. This is the sort of spirit that makes or ensures the success of a smart metering project. In Egypt, we also deployed different types of meters. We didn't just install residential meters. We installed residential meters, industrial meters, a medium voltage transformer or bulk metering. Even street lighting meters were installed in the field. And this is why, again, it's a perfect scenario to test the robustness, to test the feasibility of actually deploying a technology such as Prime PLC in the field. My question to you guys is, what makes a smart metering solution smart? Is it the metering side? Is it all of these wonderful functionalities such as time of use or step tariff, flexible payment? Is it the ability to collect data remotely? What makes it smart? It's all of that, but also it's also the communication part. A lot of people forget that the success of a smart metering project depends on the communication that you're going to be using. So am I promoting the use of PLC communication only in such a project? I don't think so. Personally, I believe in modularity. I think all of my colleagues believe that the only way to ensure the success of such a project in diverse regions is through modularity. Modularity means that, for example, in the last mile, we can be using hybrid solutions such as PLC, RS-485 for wired communication. We can also use RF communication or GPRS, for example, in the wireless sector. We should also capitalize on the WAN, the wide area network, if there's excellent fiber optics network. So why not try and integrate with that fiber optics network? Or if there's not, then we can depend on GPRS, for example. So as I was saying, if you implement such a project with one single communication type, this is a recipe for disaster. You're probably going to lose this investment and it will fail. The idea is to try and have some sort of modularity, to try and have a hybrid solution where it's predominantly using, for example, one communication type, but at the same time you have the ability to replace this communication type in the field and plug and play some other type of communication, for example. This is just basically the head-end system and what you're expected to actually collect through the head-end system and the ability that you're supposed to have different tariffs, different payment methods, all of that stuff. Of course, remote firmware upgrades. And again, another very important issue is that do you roll out all of your meters at the same time, or do you implement such a project in phases? It's very, very important for the success of a smart metering project to roll out your project in phases. Start by a small number of meters, test the environment, do some analysis of the field, do some site surveys, see what the noise levels are, and then decide on the communication type that you use. Then start increasing the number of meters. Maybe start a pilot for like 10% of the meters, and then roll out your large-scale deployments with the 90%. Don't roll out all of your meters in one go. Again, this is probably going to end up in failure. If we talk about Egypt, for example,
let's speak a little more about what we already deployed and what is happening in Cairo now, and also in the middle of Egypt as Minya. Currently, we already finished the proof of concept phase, about 500 meters already installed and running on Prime 1.4 for about 90% of the quantities and maybe 10% of quantities just for a GPRS connection as a dead point for communication. What is the conditions of the network here in middle of Egypt? We already having such a formation about already having mixture of underground and overhead cables, and already really missing the coupling, matching of the coupling in this network. As we can see, this is a real field already having and the deployment of these meters here in the blue lines already overheads, and this purple one is already underground. So a lot of network is mixed and a lot of noise we can generate it due another source of noises like these cables here and the overheads. The junction itself is not well maintained, so we face a lot of issues actually. We're starting deployment of this information with Prime 1.3, and then we're starting to move to 1.4 because we didn't find these conditions of network well running with 1.3. Moving 1.4 as a scenic band as well first. going and deploying the meter and making sure it's communication as well. But we we actually need to make some meters, some repeaters added to the network to be able to have good capabilities and readings. What is the advantage of 1.4 and one scenic band?
When we designed Prime 1.3 around 2009, we was designing this protocol for the European condition of the grid. We designed this protocol for Spanish grid and for European grid. But when we try to do Prime 1 worldwide standard, we find that we need to improve in some aspect. And this is the reason to define Prime 1.4. Prime 1.4 is the definition of Prime worldwide, to be used in any kind of network. Then, what we was changed? First, we was extend the frequency. In Europe, we are limited to the CNLK band in this time. Now it's possible to use also FCC. But in other area, we can go to not only to 100 kilohertz, we can go to 500 kilohertz. Then in Prime 1.4, we can use more bandwidth, and then we have more communication capability. Additional, with this extension of the frequency, we can use the communication not only in low voltage side, but also in medium voltage side, especially for the US grid style. In South America, in US, in Canada, could be used in some area of Asia. And additional to that, we extend the communication to provide robust communication. With this robust communication, we can manage the situation where the medium is very noisy, and then we can communicate with Prime 1.3. In Prime 1.3, in European condition, we have 99% of the coverage. But when we move to Middle East or South America or another region, the medium condition is more noisy, and then we need robust communication. And Prime, we have 4 times more robust communication than in Prime 1.3, and this could be used in the case where we need. But it's not necessary, then the baud rate we had in Prime 1.4 is like in Prime 1.3. We don't lose on that. In the case of Prime 1.4, in Prime 1.3, we use only one single channel. In Prime 1.4, we extend to 8 channels. Especially out of Europe, we can use from channel 3 to channel 8. And then we have more possibility to communicate in good condition. One important aspect is that we can use this channel, but in every connection, point-to-point connection, we only use one channel, and then all the energy of the channel is concentrated, or the communication is concentrated in one channel. One difference with other protocol is that when they extend the band, the density of the energy is lower. But in Prime 1.4, we still with the same density of energy, because we don't extend the band. We use only one of the channel. Then the signal to noise ratio usually in this band is better, because in upper frequency the level of noise is lower. We can see later.
Before going to the noise, I just need to highlight what actually we face in the field. This is actually, yes, we're already having the capability and technology giving to us. But actually, yes, we are moving in 1.4 in the field based on generic first, and we have to do 23 repeaters in the network to have good communication with all the nodes we're already having. But this was not enough for us. So we are trying to go again for channels, exploring channel 3 and channel 7 actually in the field. And now we are going back to 6 repeater only on this network. Same conditions, same location across the day. It's depending on. So to have a look about the noise in the network, here we are the profile for a certain point. Here in the low band for 100K, we already have higher noise. this is some kind of information already facing here in the network, and then we're already moving forward to it. The final consideration we already have, we're already having some readings based on this meter and getting some information, and based on daily, at least once per day readings, we already have to a success, 90% success rate for having this communication with this meter in this field. Okay. Thank you for attention, and sure if any comments or any answers any questions we can answer soon.
Thank you very much for the presentation. It was great. I think it's a very good example. Is there any question from the audience to this presentation? We have time for 1 or 2 questions if you like to. I pass you the microphone. No questions? Okay. I would like to ask one question because I think you have been speaking about one, let's say, first pilot or first project in Egypt. How would be the business model of this communication, this smart metering issue? How would you develop it? Is going to be further development for the overall country? You are starting in one region. You are going to give services. So how will be the services developed in the future in Egypt with this system? Is going to be a large rollout, or you are starting in a region? Or how will be?
Actually, we just started with Egypt, but yes, we are working to have more meters and just this one site, and currently this week we're already starting a pilot, the pilot phase to extend more meters and to be exploring the technology in another locations as well. This is for Egypt, and for sure we are planning to have rollouts for other countries. For example, we can go for Europe. Actually, we have something soon will be as well, and other countries as well in Africa. The Prime technology is now expanding all over the world, not only in certain areas.
Thank you. So we see Prime expanding around the world then?
Yes, it is.
Okay, thank you very much. Thank you. Thank you very much. And now I would like to welcome the next speaker. Here. So Mark, So I would like to welcome now Mark Gebert for this presentation on zero-touch commissioning of smart metering. Mark, the floor is yours.
Let me use this one here. Thanks, Francesco, and good afternoon to everyone. Yes, indeed. Today I would like to give you actually a little bit insight into the security part of Internet of Everything and Internet of Energy. And, I'm taking a concrete example what we have done in the UK for the smart meter grid rollout there. Just a few words. Who is NXP? And actually, we are a semiconductor company. And after the merger with Freescale, and NXP is a spin-off of Philips, and Freescale is ex-Motorola. We have emerged to the 7th largest semiconductor company, more than $9 billion revenue, 30,000 employees. And but I think more interesting is, if you see here a few markets where NXP is playing, and in a lot of them actually it's a number one. So whether it's been automotive in secure identification and or RF power transistors, and particularly we're also strong on the processor and the broadband MCU side. And you see artificial intelligence, no numbers there. I think it's a bit early to say who is really number one there. But it's definitely an area where NXP is playing very strong. So now, when we look at, and you see our company slogan is actually secure connections for the smarter world. And so when we look at this, the Internet of Energy and applying also here, you see everything is becoming smart. That means everything will have some type of processing into the devices, be it in the meter, be it in the gateway, or in further sensors if you think about building technologies. All of those devices actually also get connected. We have seen power line communication before. There are obviously a lot of other connectivity schemes there. and they get connected then among the devices or to the cloud. Now, when the two things come together, a device becomes smart and the device becomes connected. There is actually a very high risk profile for those devices to get attacked. And if you speak to some people, they said, well, they will get hacked as soon as they are being exposed here to the Internet of things. So everything needs to be therefore also secure. And there is a big economical impact actually when doing security right or not doing security right. So that's really within our, let's say, genes of the company, what we believe on. So processing, connectivity, and security. Now, question comes, what will change when transitioning from the smart energy to the Internet of everything? And well, devices will become smart or smarter even, and they become connected as shown before. And that making it vulnerable for attacks. Devices need to connect now to the power line and to the IT network or cloud. That actually means they're requiring solutions for easy installation and provisioning to the cloud. Think about that. You don't want to have an IT expert bringing the device to life in the field. Now, since there is some investment to be done, actually operators looking for incremental revenue opportunities. And for this, they're looking at new partners and services. That means the device itself, the smart meter, the gateway, the hub, they need to carry services from several stakeholders over the product lifetime that need to be managed and traced back. Right? So this is what we call the new reality here. Now, how are we gonna cope with those realities from a security point of view? There's a security by design, but by the way, it's not it's not a synonym that's being invented by NXP, but strongly contributed to, and it actually relies on and means that your smart and connected device need to guarantee availability, confidentiality, integrity. That means you know your device and the data, and authenticity of the data. And they must be combined in systems to offer now an end-to-end security and comply with future standards and counter potential attacks. And that's a big promise, right? Think about we have certain regulations today and certain standards, but those devices are being in the field for 5, 10, and more years. And you still need to cope with the vulnerabilities and the attacks and that are evolving over time. So that's being covered by security by design. Now, there's also responsibilities throughout the digital supply chain and throughout the full product life cycle. This means that the authenticity and integrity of the data and the device has to be guaranteed from the board assembly to the first power on of a device, and it then continues to the cloud provisioning. So you connect your smart meter, your gateway to the cloud. The operation, updates of software, firmware, security patches, until the device is actually decommissioned. Many people forget about that part. So these are the fundamentals what we clearly work on and in our own organization as well as working with our customers. Now, let's take a look what security by design actually means in practice. And it's four principles, and they're quite easy to remember. You know, what we say is keep your secret secret, like in a tamper-resistant hardware to prevent the cloning of your device, protect against unauthorized access and misuse by third parties. The next thing is whenever you have devices communicating either between one device or the other, or the cloud, you want to secure, you want to encrypt your communication. And so no one can listen what devices talk, right? Now, the third element is you want to know your smart meter you are communicating to. Is it actually your smart meter? Or did someone replace it by, it's looking almost like yours, but not exactly, maybe a different firmware on. So it's very important that you provide a device with a strong and device individual identity, right? To trust the device and actually restrict access. That's addressing know your device. And finally, you want to secure user identities separate from device identity to respect user rights. And that's actually also being asked by the General Data Protection Regulation here in Europe. Now, let me give you one example where actually NXP Security connects the UK smart energy infrastructure. And the UK is actually to deploy more than 100 million pieces of smart energy equipment to optimize energy management in the country. And this includes the communication hubs, the gas and electricity meters, and in-home displays. And NXP will actually connect a large part of the UK infrastructure with the security IC, enabling a zero-touch commissioning of hubs and smart meters. Now, let me show you here how this zero-touch provisioning actually works. Meters and communications hubs in the process of being rolled out in the UK and must fulfill security requirements that are set out in so-called GBCS specification, as well get certified against Consumer Product Acceptance, CPA. This includes protection of device credentials. And when we security people speak about credentials, it's nothing else than your secrets, right? This can be a certificate or a key. So you want to protect them of those credentials, and a pre-injection of digital certificates to connect automatically the first time the device or the meter, the hub, connects to the UK Smart Grid Data Communication Center, the DCC. It's a central hub that is collecting smart metering data in the UK. Commissioning time of meters and hubs is key to achieve a successful and cost-effective deployment. Now, NXP's security IC, and thanks actually to some hardware that is based on banking-grade security, ensures easier and faster compliance here to the CPA, reducing for OEMs uncertainty around compliance. OEMs don't know what to really, how they're going to achieve these CPA requirements, certification of the device, and actually time to market. Now, let me show you the requirements in the UK, and it's starting with a connection and authentication of data with the DCC. It's a connection to the home network, it's a connection to the WAN network, which is being via ZigBee, and secure over-the-air updates. So all these associated certificates, what you can see here, are enabled by a pre-provisioning service from NXP, associated with one of our security chips, and leveraging actually a certified trust provisioning infrastructure within our own chip manufacturing. It's basically the same manufacturing process we are using when we are shipping chips to the banking industry or for national ID or passport programs. So now the security chip So these credentials are now inside this this security chip, the security wall, and the security chip will, with the secret credential, will be locked and shipped to the hub and meter manufacturer or contract manufacturer facility. And this actually reduces further time to market for the OEM, allowing them really to focus on core meter features and avoiding significant efforts to set up and connect a key management system, what they would otherwise need to do. It avoids the cost of ownership of such a key management system, including some initial capex, its setup and compliance procedure, but also OPEX for operation and maintenance. Think about that one, as a large provider of security chips, there is some economic of scale and efficiency, obviously, what we can offer here. And finally, it removes, and that was an important part for our direct customers, these meter companies, it removes some stickiness and trust requirement with specific contract manufacturers, recreating a flexibility in their commercial manufacturing agreement. It gives them much more power in the negotiation now where they're going to produce this secure product. There's another benefit for the OEMs, because the device security characteristics gets now separated from the application. If you take a device, right, and you just say this is the part that is running and processing my main application versus the security part. This will simplify the product assurance and changes in the device application, and actually without having an impact on the security characteristics. So the assembled smart meter hub now gets shipped to the home end user, where the hub auto-connects to the cloud, based on the pre-injected certificate here from the UK DCC. And what's the benefit, and what's finally the economic value for the UK utility companies, why they also like it? And they benefit from being able to roll out the smart meter hub through their established technician workforce. Think about who are not network specialists. Think about that. I'm sure you know that. This is, they have a technician workforce long for many, many years, rolling out analog meters, and now suddenly they come to the world of IT and IoT. That means actually that no IT expert, in addition to the utility technician, needs to be sent to the home for connecting the device to the network, and reduces cost and time to market further. At the same time, the smart meter hub is fully trusted now and secure and set up for being actually also GDPR compliant. Again, if you're following privacy by design and taking all the measures to secure your device. Now, in summary, there are benefits for multiple stakeholders, as demonstrated here in the UK smart metering rollout. There is a data service provider who's being allowed now for an easy setup and control of multi-party services and key management solution. This is the initial rollout, right? But the question is, what service going to be there in the future, and how you're going to add them to the device without compromising security, and at the same time keep control over your platform, right? Because you're opening it up, and that's a very nice solution for them. The OEMs actually benefited by achieving a simplified and improved supply chain flexibility here, now since they are shipping a security product. And the utilities, they can now realize a secure, through a secure and zero-touch provisioning to the cloud and easy field installation of smart meters, basically getting this technology, getting this new product out with their existing technician force there. So this was an example from the UK. I have one more to share, which is the German smart meter gateway, and Francesco already highlighted to that. That's just about to roll out. That's definitely some delays there. But When it will roll out, NXP actually will supply here also the security IC, which are certified according to common criteria EAL5+ to the German smart meter, which is actually the base now for achieving the smart meter getting certified according to common criteria EAL4+. So message is just this one: depending on the country we are going and you are in, there might be certain certification requirements there which you actually can achieve here with those security ICs and this technology from NXP. Now, one word to GDPR here. And in the world of Internet of Energy, protection against cybersecurity is actually tightly connected with guaranteeing data privacy. Why is that? Well, simply because your connected device may carry personal data and send it to the cloud. And as we have learned, or at least I hope you're aware of that, and so before, okay, everything which is connected and smart can get attacked. So since May this year we have the GDPR, and I believe most of you know the 5 main customer rights and its dollar impact for companies. And I explained before the principles for security by design for connected devices, which are actually also the baseline for the to become GDPR compliant, right? So it's about security and privacy here. Now to my final slide here, I would like to conclude it with a cartoon, and you see the bear here running after Tom and Peter. And Peter's saying, "Hey Tom, I just realized that I don't need to outrun the bear, I only need to outrun you." Well, if you think about it, the same applies for security and privacy and connected and smart energy devices, right? Think about it that way, and I think our message, it's an equal playing field for everyone, and we see companies taking it actually an advantage to provide security and privacy to their devices. With this one, I'm ending my presentation and opening it up for Q&A.
Well, thank you very much, Mark, for this very, very good and challenging issue of security and privacy. I would like to open the floor for 1 or 2 questions to the audience. I think after lunchtime, this is a hard moment for everybody. I have one question, because you have been mentioning quite a few things, and also in 2 different markets, UK and also the German market. Let's say if there's a new company starting to do some kind of rollout or some kind of, let's say, assessment of security, what 3 key messages or key aspects they should consider to start a strategy for this?
Sure. Well, for me, it starts with the organization, and just very briefly, people have security policies in their organization. It needs to come from the very top, but you also need to think about how you're going to implement it, right? Is it a consultant, and do the people who are creating devices, and that's where we get involved, right? When people making new smart meters, do they have the same KPIs, or is it only cost, bill of material, and time to market, which are absolutely one. So this is one. Second one is think about the principles of security by design. Yeah, those four measures. And the third one, what we see is everything in this connected devices, you need to think about it end to end, and there is no one company that can provide this all, so partnering is very key. We do that at NXP, and depending on the project we are engaged, we are bringing in partners, and we have an extensive partner network. All right, thank you.
Okay, now I would like to welcome the next speaker. We have Inigo Larumbe from Iberdrola, and he is going to speak a presentation about the rollout of Iberdrola smart meters.
Ok, esto es para adelante. Okay, good afternoon everybody. It's very cool, make a presentation with the headphones. I feel like David Guetta, make a concert, but anyway, it's not the case. Okay, I will try to show you the past, the smart meter rollout that we did in Spain. We already finished, the present, and the next step we are going to do. So first of all, just looking at the past, 10 years ago, well indeed 11 years ago, there was a royal decree coming from the government saying that we should remove all the meters that we have. Indeed, we had 11 million meters, damn meters, and we had to remove in 10 years. So the functionality, I'm not going to bore you, the functionality is more or less the same functionality that we have in all the massive smart metering rollouts. So the challenge for us is that we started not in 2007, we started a bit late, and we had to finish before this year. So we are there, and we are in the 99.9% because there are some houses, you know, that we are knocking on the door and the house is empty, so it's impossible to access to the meter. Okay, so we call the project in Spain, we call it STAR. STAR means massive smart metering deployment and automatization of the network. Okay. We had 4 options in 2007. We had 4 options just to go ahead. The first option was just to buy a proprietary solution. That is more or less the case of the States, the New York, and the North America. It's more or less you buy a proprietary solution, and this solution is the unit that you deploy in the field. The second option should become a meter manufacturers. Was not our case. There are other utilities that could be a meter manufacturers. It's not our business case. The third is do nothing, just wait and see. We started in 2007, but other utilities can wait and see what Iberdrola is doing, and if the results are good, they can go ahead. And the 4 options that we chose is just to starting from the scratch, but not from the scratch, with PLC communication based on open standards, no royalties, and looking for the interoperability that we are going to see later. So this this PLC solution is called Prime. Nowadays, many people know Prime, but we started in 2009 with some small devices, and nowadays it's an ITU standard. Okay. So we are talking always in PLC, that is the communication layers, but we are more focused in the application layer. We are using DLMS. As we know, DLMS is a standard, a very good standard. Indeed, in Europe, I think it's one of the major standards. In France, they are using it. In Spain, we are using it. We are seeing in Latin America, DLMS is also part of the standards that they are using there. And we are so happy with the DLMS. We are going to see later that DLMS will be the protocol chosen for the next steps. The good thing here in Spain that all the specification, the functionality, we share between the major utilities here, like Unión Fenosa Distribución, EDP, Energía, Iberdrola, CIDE, and ASEM, small network distributors. So this is the schedule that we follow. I think this schedule is very important because before going to the field massively, we need to test step by step. So the first three boxes are related to the official certification, I mean MID and so on. So we are out of this business. Of course, we ask for this kind of certification to the meter vendor, and the meter vendor send to us the report saying that they are certified. Okay. The fourth and fifth box is related to Prime and DLMS test book. We wrote a very huge test book in Prime and in DLMS, trying to test all the functionality that we wrote in the paper, because the paper holds everything, but it's important just to put all the effort just to write use case by use case and to see if everything works. After that, of course, we are talking about interoperability, but it's very interesting. So I can assure you that it's easier just to buy a proprietary solution and go ahead with that. But we wanted interoperability for many reasons, and it's very hard just to test all these things. If you see our lab, we have 9 different smart meters, 3 different concentrators, 1 system. So all the communication is fluent from the system to the meter, whatever the concentrator is. Okay, and lastly, but is I think is one of the most important things, is just to see that this communication version will be succeed on the field. Okay, because as you know, you can certify everything in a lab in ideal conditions, and then you go to the field and it doesn't work. So we try to reproduce in the same laboratory with 350 meters, with noise conditions, with long wires, with everything, just to see that this version is going to communicate also in the field. And after all these tests, we go to the massive deployment. Another thing curious in Spain is that in Spain, the rental price is fixed by the government. So we buy the meters, we specify almost everything, but the rental price for the meters is done by the government. So it's important, the cost, just to make a cost-benefit analysis, it's important to have a very cost-effective prices. And you can see there, in the beginning, in 2010, you can see there are no prices. There are base 100 price. You can see the decrease of the prices of the meters. Why? Because we had 9 different meter vendors competing for the same market. So you can see there a picture of the 9 different meter vendors that we have. It's good to see that, well, there are 4 major vendors in the field, but if you see 0.75%, you see, well, it is peanuts, but 0.75 is 100,000 meters, so it's a huge number. So we call that from the obligation to the opportunity. So once we had to deploy the smart meters, and once we had to install a data concentrator in the secondary substation, we took the opportunity just to put something else in the secondary substation. And we put supervision, and we put automation not in the whole secondary substation, but we select some of them. Basic supervision we launch in all secondary substation, because it's a card that is a meter included in the data concentrator. So it's very easy to put it. And this is the architecture. It's very easy. We divide it in remote reading. Remote reading is automatically the concentrator asks to the meters every day the remote readings. and the meter responds to the data concentrator and send it to the system, okay? And the operation is different because the operation comes from the MDM. Cut-off, reconnections, program, tariff reprogramming, whatever, comes from the billing system, okay? But in some seconds, we can manage the operation and the remote readings. And of course, cybersecurity architecture, because we have seen some presentation here. Cybersecurity is one of the main topics in the smart metering deployments. As I said before, we have PLC Prime in low voltage network, DLMS COSEN, and different kind of communication between the secondary substation to the system. We have PLC, high voltage, GPRS, ADSL, whatever. This is some KPIs. I don't want to bore you about the KPIs, but we are very happy. We have seen in the first presentation about the Prime 1.4. We have Prime 1.3, and we are very happy. And I think the most important thing here is firmware upgrades. You know, when you start a massive deployment in 2009, and the lifetime of the meter is 15 years, so you need to perform very well the firmware upgrade because the technology is not the same 10 years ago. We are talking now about the Prime 1.4, but we are starting with Prime 1.2, and we went later to 1.3. So it's important just to have the possibility to upgrade all the meters. We upgrade many meters because we are started with low-level security, and nowadays we have 95% of the meters with high security, authentication and encryption. So regarding this slide, I would like to show you that regarding resources is a very challenge also. We are talking about technology, but the people has to receive training. We fully offshore all the installation process. In Spain, it's very easy to remove the meters because we have 75% of the meter in the same location. They are all closed in the same cabinet. So in Spain, only 25% of the meters are individually in the house. Another very important thing is consumers, because we are looking at the consumers, but this topic is more about the benefits of the smart metering rollout. So the benefit for the utility and for the customer, because here, if you see quality of supply, it's a benefit not only for the utility, but also for the customers. We have a network also in the North America, and you know, when a storm happens, maybe they don't have light in 2 days. Incredible. If you live without light, without supply in Spain for 2 hours, you receive many claims. So it's very important. As you see here, the interruptions, the losses, we decrease a lot the losses. Fraud is also very important in the smart meters. And of course, we are billing with real readings, so we receive less claims for the customers. And the next one is also very important. Is there any home display manufacturer here? No? Okay, I'm fine. So our message is that having all the technology in our laptops, in our mobiles, in our tablets, we think that we don't need an in-home display in our house, because it's another device that we have to put on the wall, and I don't know how many times do you check it. But having a tablet and having a good performance communications and reading every day, we can show to the customers daily the load profile, the hourly load profile that we have in Spain, the daily billings, whatever, with easy access to one application in the Iberdrola distribution website. So it's very easy to see all the consumptions. You can download in an Excel sheet. You can make a pin to the meter directly. In some seconds, you receive the instant energy. You receive the power consumption that you have. In Spain, we have a power contract, so it's very good for the customer to see if this power contract, it's the power contract that he has is the power contract that he should have. So the customers here in Spain pay a lot for this power contract. So it's important just to fix the power contract according with the consumption, okay? And we show all these things. And we can make scenarios. Scenarios means that you program just to read each 5 minutes the meter. And you put that for 2 days, and after that, you can go inside the web and you can download the curve of these 5 minutes for these 2 days. It's very interactive and very easy to manage. So what next? So the next thing in Spain is to have the 100% of the smart meters that we have in the field with remote connections. So in Spain we had 5 different types of customers, you can see. So the mandate for smart deployment, it's only affected to type 5. But instead of that, we are installing smart meters not only in the 5 type, but also in the type 4, sorry. Our idea is to put smart meters with PLC in all our low voltage network, because we have the data concentrator in the secondary substation. So it's very easy to populate the low voltage network with smart meters. What happened with the smart meters in the high voltage? So it's very easy. We put a modem just to send the readings once every day, and for that reasons we will have our target is just for 2020 to have all the population, all the meters with remote connections. The same, this is something that many people is talking about, IoT and distribution, energy resources and so on. Nowadays there are only one flow, and within the future will be many flows, import, export energy, connection with another devices. So it's a big challenge for the utility. And this is a picture about the 4 countries, the 4 regions that we are based. We are based in Spain, so in Spain we finished the smart metering deployment, but we are thinking about the 2nd generation. So we are rewriting what we need for this 2nd generation. As I said before, the lifetime of the meters are 15 years. So we started in 2009, so in 4 years we need to think about just to remove again all the meters. So yeah, we are thinking about that. In UK it's a totally different position. UK, it's coming for the government, so we know that the DLMS is pushing a lot, but it's difficult just to explain. And also, I'm from the network business, and in the UK is retail business. So the next challenge for us is Brazil. We are based in Brazil, and we have there 40 million meters. So you can see here, we are going to test the radio mesh solution, Wi-SAN, but on top of that, we will have DLMS as well. And in main, of course, we are pushing of open standards, interoperability solutions. And finally, so that's the thing that we take in Spain. but that will apply to all the countries. With instead putting that PLC will be Wisan, but DLMS will the data protocol, and we are looking for low-cost solution, open and public solution, interoperability, and of course, high performance. That's all from my side. Thank you.
Wow, lots
in time.
Just in time, and lots of information. I think you are doing lots of things, and also I see different strategies in different countries, which is another challenge I see. But in Brazil, 14 million units, so it's with a different strategy, I guess, as I see.
It's just to start from the beginning again.
Something simple then.
Yeah.
So I would like to open questions to the audience. If you have any questions. Yep.
Marek Pinkas from Poland. You have presented a very successful picture of the implementation. And I would like to ask you a kind of tricky question. What obstacles have you faced? What failures have you faced?
Yeah. This one. I think this one is very important. So the obstacles are more or less having 9 different meter manufacturers. It's not the obstacle, it's a challenge. So I say the obstacles because it's hard just to put all the interoperability in 9 different manufacturers and just to see the good performance in all these 9. Another obstacle for PLC could be noise of the network. But honestly, we thought that the noise would be worse than we have in Spain. Because we install filters just to avoid this noise, but we install thousands of units, and we have 99% of the readings. Another thing is not an obstacle, it's a hard work, is the resources. It's a big effort of training, because we started maybe 10 people working in this project, and at the end there were 400 people working in this project. So it's important just to share all the information, all the experience between all the people inside the company. So this is more or less.
So perhaps another question following the first one. What about logistic? Logistic of transporting the meters, installing them, and workforce necessary for that. How much that is a difficulty for the project in the massive rollout?
Well, the good thing of interoperability is that the meter is more or less the same, because we define the display codes of the meter. So interoperability means that you take one meter from one manufacturer or another meter from other manufacturers and you put in the field and it works. So for the installer, it's a meter itself. So it's plug and play communication. So the installation is very easy. The installation is put the meter, put the optical port with the tablet, push OK, and the meter is reprogramming automatically. So for the installer, it's very easy. And as I said to you, in Spain, 75% of the meters are all together in the same cabinet. So for the installer, it's very. We have a number in 2013, 2014 that we were installing up to 13,000 units per day. So it's a crazy number. Yeah. And we finished before the timeline. So the timeline is December this year. And since last year, we are in the 98th. But you know, the queues that we have is because some customers don't want to open the door, some claims, some complaints about that. So We finished last year. We almost finished this 98% of the population, and we started in 2010. So in 7 years, we removed these 11 million.
Thank you. Very interesting question. Any other questions from the audience? I would like to ask one question, which is also a tricky question. Which is the cost of a smart meter today for Iberdrola, and which is the payback period for the smart meter?
So it's a very good question, and it's very good answer saying that, oh, sorry, I'm technician. No. I cannot talk about the price because, you know, I cannot talk about the price. I can say to you that the price is very good for us, and we can return the investment of the smart meters with this fixed rental price. And you can see there, we are so happy. So we are extended the smart meter rollout, not only focus on Type 5, but also focus in Type 4 and Type 3 low voltage network. So that's why we think that smart meters has a very competitive price. And that permits us to return the investment.
So if someone wants to sell meters to Iberdrola, I would say no more expensive than 50 euros. Is that okay?
I don't know.
Something like that? Okay. Thank you very much, Inigo. Thank you for the presentation. Really lots of information. Thank you very much. And now I would like to welcome Colin. He will speak now about another very interesting topic, optimizing service delivery. So now we are talking about providing benefits for customers and utility companies simultaneously. Correct? Thank you, Colin. The floor is yours.
Thank you. And perhaps during the presentation, I will address the question that we had from our colleague there from Poland. So I'm changing tact quite deliberately here in this presentation. I'm not here to talk about devices specifically. I'm more here to talk about the business processes involved in the deployment and mention specifically some examples from a customer implementation that there's been in the UK. So we're a software company, IFS. We're a software company with an enterprise offer that specializes in field service. And within our customer base, there are a number of organizations that have gone through a smart meter implementation program from a sort of service management perspective. But the one that I'm going to focus on most during this presentation is National Grid Smart in the UK. National Grid Smart was a company established in sort of late 2016, early 2017, from a very low base, of course, because they were a new division within an existing organisation, and they were tasked with getting an operation off the ground very quickly to meet the ongoing challenges that there have been with the UK smart meter program. I think, you know, there are anecdotal rumours that they were approached by senior people and asked to set up the company to address this problem, because there is concern in the UK with the pace at which the smart meter rollout program is moving. But if we think about the specific challenges that they had as an organisation, so as I say, they were starting from a greenfield establishment. It was a new company. But they were required to get a business solution, a field management solution, implemented in a very short period of time. And of course, what they wanted was a fully comprehensive solution, something that would cover everything from finance all the way through to human resources, with, of course, mobile workforce management in the middle, and especially managing all of the inventory challenges that you've got around receiving stock, issuing it out, returns, and that sort of thing. They clearly, as they got going, had the need for subcontract resources to physically install the devices into the properties around the UK. And they really wanted to optimize that resource planning element of it, because recognizing that you know, if there's going to be a return here, then we've got to get a process that is extremely efficient and extremely cost effective. And then would you believe, finally, the challenge that they had was, having got the organization up and running in a fairly swift way, they actually had to sort of revert and sort of reanalyze what part of the market that they wanted to be in. So they needed to sort of revisit the strategy that they had defined. So if you think about a normal sort of business solution implementation, if you're looking at most business solutions, you know, you should really be able to get a solution up and running with something between sort of 6 to 9 months, yeah? And there are the various phases that you would expect to go through. But the demands here were far more compressed than that. The challenge that was given here was that a finance solution, a basic finance solution, a basic procurement solution, and a lean CRM solution had to be up and running in 9 weeks. And what that involved us doing together with the customer was clearly defining an agile approach that involved lots of demonstrations of functionality, how the system would be established, how the system would be set up, how the system would be used. And we did that in a sort of sprint methodology, that every couple of weeks we would demonstrate to the customer the solution and get acceptance to move forward. And that was how we managed to achieve the objective of the finance and supply chain solution within 9 weeks. And then the full solution had to come another further 16 weeks after this. And that required the management of all of the inventory, the management of appointment booking, mobile working, mobile field force employees utilizing the latest mobile technology to book in the work that they've done, to receive the meters back, to issue them out from their van stock, and as I've mentioned, also manage the whole subcontract process as well. And you know, that was something that was an extreme challenge, but was able to be overcome through this lean, agile, sprint-based implementation approach. I mentioned that the scope of the solution was extremely wide as well. So, you know, they needed to get a full chart of accounts up and running, full forecasting and budgeting, full accounts payable, full accounts receivable, all within a relatively short period of time. It wasn't a huge challenge because it was, as I've mentioned, a sort of greenfield setup. They needed to get a supply chain solution up and running quickly so that they could go out and provision and pay for the meters and set up supplier agreements, look at all of the different manufacturers that were out there, all of the different meter suppliers, and just get agreements in place to purchase meters from them. They clearly needed to pre-register those meters before they got receipted into the DCC, as was mentioned previously. In addition, they wanted to manage the inventory all the way through the delivery process, and that included potentially leasing the meters and invoicing for the lease of the meters, as well as fitting them and owning them themselves. As I mentioned, a very thin CRM solution had to be implemented, and this had to be fed from many other disparate systems around their IT landscape, and from third-party inputs as well, from various gazetteers to list the properties, start to analyze where meters would probably be most accepted around the country. All of that analysis had to be done as well. An important element in the UK was that as an organisation that was bidding for work in the smart meter programme, they could be replacing meters belonging to a number of different suppliers. And thus the challenge around the reverse logistics element of making sure that ownership was understood, that meters were effectively tracked and stored and warehoused, and all of the communication was sent back to the suppliers before those were effectively disposed of. And then finally, the other major element of the solution clearly is around mobile field force working, mobile working, including, as I've said, sort of subcontract management. So how did we address these challenges? Well, first and foremost, we utilised the appointment booking capability, the solution that we have that underpins our resource optimisation. And what this would do is this would look at the availability. It would present slots for contact centre staff to offer to customers over the phone. This was also able to be presented back into a self-service portal for consumers if they wanted to book their own appointments. And you know, the whole way in which this was optimized was to ensure that the best appointment was offered to the consumer that fitted the most optimal way in which we would set up the resources. And you know, there's so that we could ensure that this scaled as a solution. We had to ensure that as requests would come in, and some of these requests could come in automatically from other systems, you know, that there was an immediate offer of an appointment. So response times were in the regions of sub-second, increasing to 1 to 2 seconds, dependent upon the volume of appointments that were being thrown at the scheduling engine. And you can see that here we tested this up to, in fact, just 10,000 activities, all requesting appointments at the same time. So we could simulate the simultaneous processing of all of those sort of requests. What clearly sits behind the appointment booking is a service request. Once the appointment is scheduled, the slot is booked, then effectively we are now passing this particular job out to either our own direct staff, National Grid Smart direct staff, or some of the third-party supply chain partners that they have contracted with to deliver. But there is still a requirement to optimize and schedule the jobs effectively, ensuring that all of the real-time challenges that occur during the day are met. Jobs would take longer than you would expect. There would be, unfortunately, unlike the Iberdrola example and the Spanish example, you know, the state at which meters existed in properties in the UK was extremely varied, and you know, it was very difficult to set standard times for a meter replacement. Often 2 or 3 other providers would potentially need to come in because there was some dangerous wiring activities, maybe some fraud where the existing meter had been bypassed. So there were all sorts of challenges around the actual setting of timescales, and thus the ability to dynamically reschedule, considering all of these, as well as the obvious things such as appointments being cancelled, extreme weather, follow-up required, you know, all of those sort of things ensured that, you know, the sort of service level agreements that were met were exceptionally high. Clearly, once you've sort of scheduled the job and you've issued it out to the technician or the subcontractor, there needs to be an extremely straightforward, simple workflow to book in. And these are just some examples of that, including health and safety information, ensuring that there is a commissioning protocol on the device that the engineer or the technician can follow through, and that's shown in the third screen, and the ability to get to run through a customer satisfaction query, especially when you were expecting to set up some sort of in-home display or take the UK consumer through how to use an in-home display. So having got everything up and running and started to fit meters to walls, and of course recognising, as I'm sure you're all aware, the challenges that there were in the UK around the SMETS 1 and the SMETS 2 programme, you know, it gave National Grid Smart an opportunity to reevaluate the strategy of the organisation, if you like. And what happened then was they utilised an operational intelligence capability. They reassessed all of the processes, all of the ways in which the organisation was set up, you know, how they actually onboarded customers, how they managed campaigns, the service intake, all of the different ways in which the data would come in, and how that could be validated, and any errors in data could be managed and corrected, through to sort of service planning and service engineering. And this effectively highlighted a new set of different challenges. So the system's up and running, meters are being fitted, but there's still a need to increase the data quality, maximize the technician productivity, improve first-time fix rates. As I've mentioned, sometimes it would be able, this capability, this operational intelligence toolkit, was able to sort of project where the challenges may be in respect of the duration of the task. So by definition, if it was thought that a first-time fix was not going to be possible, then the way in which the job was skilled, the way in which the job was resourced was clearly changed automatically by the system. And ultimately, you know, this desire to think about leasing and renting out the devices, again, proved to be important in respect of increasing potential service revenue. And these are some of the figures that have been realised by the company. So 20% improvement in SLAs, on-time service delivery, 40% improvement in engineer utilisation and reduction in costs, and a greater reduction in analysis and reporting. So just finally, I realise I'm heading between yourselves and a coffee break. Yeah. So what are the benefits that both the consumers that have experienced this engagement with the organisation and the organisation itself? What have they realised? Well, as I've mentioned, you know, the revenue improvements have been considerable. The capability of providing to the third-party technicians portals that allows them to book in work, mass update what the work that has been done. The portal capability to allow consumers to self-service their meter installs. The important criteria to be able to engage with consumers in a very modern way in which all of the different omni-channel interactions that can occur these days in respect of Twitter, email, voice, text, Facebook posting, all of that potentially can all be put into the organisation and managed through a sort of customer engagement capabilities. And finally, as has been mentioned previously, I think from Mark, when he put up the slide about the UK infrastructure and the DCC and all of the communication that is going on, it's extremely important to be able to message directly from the system up to the gateways that allow messages to move into the DCC. So having a very open, flexible integration framework allows you to do all of that. So whether you're pre-registering devices, whether you're notifying that devices have been fitted, whether you're notifying that devices are not working and have been replaced, you know, that sort of communication messaging between the business solution and the communication hubs is critically important. And within this solution that was implemented here, you've even got the capability to integrate off to other enterprise service providers. So that's me. Thank you very much.
Well, wow. Again, a lot of services in one platform. I was thinking this was going to be more focused only on the, let's say, equipment, but you have been speaking about financing, about customer, about, well, all this. Well, first of all, any question from the audience? Because I have always many questions from myself, but I have an agile mind. Is no questions about this platform or services or something you don't agree? You disagree? Okay. I have one question is, because now more and more with all these massive rollouts in many countries, there is a lot of need for the asset management of all these equipments. Usually you find in the same company several platforms doing different things, and sometimes not easy to integrate all this information. So how does your service, or because this is service, I guess, is a platform plus service, how does this benefit or improves the situation, let's say, from a utility, or is for utilities mainly, also governments, or is mainly utilities?
Yeah. No, I mean, it's for utilities. I mean, we're here talking, obviously, about the sort of smart meter programs around the globe. But, you know, this is a solution that can manage assets in generation, transmission, as well as, obviously, clearly distribution. I mean, we find, obviously, customers that have a number of disparate systems. You know, it's clearly a challenge. I mean, we would like to propose that you know, all assets can be held in one system if that system has got the flexibility to hold all of the relevant data against those assets. And typically, legacy systems are all built to hold specific types of data about specific assets. If you've got a system that is flexible enough and open enough to be able to be configured to hold everything, then, you know, why not try to get all of the assets into one system? It's a very easy system to load asset data into in volume, and you know, it provides that capability for sure.
And your platform uses, let's say, cloud services?
Absolutely,
like Amazon Web Service or something like this, or
other, Microsoft Azure, typically from a cloud perspective. It can exist on Amazon Web Services for sure. But most of the deployments have been that way. But it's a deployment by choice option, whether it needs to be on premise or in the cloud.
Okay, thank you very much. Before we leave for the coffee, I have one question for Inigo, if you don't mind, because I was thinking something because you are finalizing the rollout of smart metering, and well, in principle, people could think, okay, you will continue with Prime, same kind of PLC and so on. You are thinking about something else? Iberdrola is thinking about something else? Or in principle, same Prime, same, yeah, please. This is it.
So depend on the network that we have in Spain, for instance, we have the average of 150 customers per secondary substation. So it's the perfect place to put PLC network, because we have around this number PLC network. The topology is very good. If you see the North America, is the opposite. You have 2 or 3 customers of each secondary substation. So for sure that we are not going to put PLC there. We are not crazy. We are not pushing PLC because we are Iberdrola and we need to go ahead with this solution. No, no. And in Brazil, that is a mixture. We are running a pilot nowadays with 75,000 customers, 50% radio Wi-SAN, another 50% PLC Prime. So depending on the network, we are going to use radio mesh or PLC. But the critical thing for us is if you use radio or PLC, it has to be open standards, interoperability, and so on. This is the critical. And of course, DLMS will be on the top, not depending on the technology, because the data protocol could be the same for both technologies.
Thank you so much for answering this attack question in the last moment. Thank you. Okay, any other questions for Colin? Or okay, then I would like to ask if Mr. Andrew Shaw is here today, because we have a speaker that didn't show. So okay, not here. Okay, so we have a coffee break now, and then I will like you to come back if possible by 4:15. So we have 15 minutes more of break because the first speaker is not here. So we'll continue at 4:15. Okay? Thank you very much.